if I think that I forgot to tell you last week why they're called conic sections. Okay? They're called conic sections because it's all about how you slice a cone. Okay? So if I slice a cone vertically, that gives me a parabola. If I slice a cone horizontally, that gives me a circle.
Wait, what?
If you take a cone, right? Okay? So think of like the old sugar cones that you used to make ice cream cones with, right? Because those are actual cone figures. If you slice it horizontally, you got a circle. You're looking at a circle. You sliced off a circle. Okay? If I slice it vertically, I'm left with a parabola. Okay? If I slice it at an angle, I get an ellipse. Okay? It's all about how you slice the cone as to what conic section you get. Okay? Okay? So today we are going to hit up ellipses. We're going to do that diagonal at an angle slice. Okay? So I've got two different ways of showing you what an ellipse is. The first way I have is, that's not working. The first way I have is here, on this. Okay? And that's great and all, but in the room, I also have this ellipse over here. Okay? And so what an ellipse is, and the only part of this site that I don't like, I love all the interactiveness of it, but I don't like curved lines, because that's an oxymoron to me. Lines are straight. Okay? So you say curved line, it's not a line, it's a curve. Okay? So it's a curve forming a closed loop where the sum of the distances from 2 points, we call those 2 points the foci, to every point on the curve is constant. So over here, this point has this distance plus this distance. That is the same as this point up here, this distance plus that distance, is the same as this point over here, this distance plus that distance. It's all a constant. On here, if I drag this point, that point around, and you'll see up on the top, right above it, so it always has red plus blue is always the same. No matter where I go on that ellipse, red plus blue is always the same. Okay? So that is what an ellipse is. So we have more parts to an ellipse than we had in a parabola, than we had in a circle. Okay? So the function, or excuse me, I shouldn't say function, the equation of an ellipse is this. Okay? X minus h quantity squared divided by a squared plus that equation. First thing is that it is always equal to 1. Okay? Always equals 1. Second thing is that A cannot equal B. Okay? A cannot equal B. Because if they are equal, then we have a circle. And we go back to all of those circle formulas that we had last week, which weren't that many. Okay? So A and B are going to be different numbers. We'll talk about this in a minute, but whichever one is bigger, A or B, is going to determine what our ellipse looks like. So if A is bigger than B, we're a horizontal ellipse. Okay? It's stretched out horizontally. If B is bigger than A, then we're stretched out vertically. And so then it looks like that. Okay? So if B is bigger than A, it's vertical. If A is bigger than B, it's horizontal. Okay? We see ellipses all over. Okay? Planetary motion is an ellipse. Moving atoms and electrons moving around an atom is an ellipse. Some buildings, like that cool building up on there in the upper right, that's the roof is an ellipse. Okay? Some billiards tables are ellipses. Billiards is different than pools. Billiards doesn't have pockets. They play. It's all about hitting sides. You have to hit a certain amount of sides before the ball that the cue ball that you're shooting can touch the other ball. And then afterwards it has to hit a certain amount of sides. It's all about geometry. Billiards is all about geometry. The cool thing about the two rooms down there at the bottom, on the left and on the right, the one on the right is in London, and the one on the left is at the U.S. Capitol building. And it was the original House of Representatives, the one on the left was. And what happens is, if you're standing at one foci, you can hear the conversations going on at the other foci. Clear as day. Because the sound will bounce off the walls, and you're standing foci from foci to foci. You can, so like if I'm standing at a foci in a crowded room that's elliptical, and Alexis is standing at the other foci, I can just sit there and talk to Alexis. We can talk like that back and forth with one another. Or I can listen in on Alexis' conversations because I can hear her out. Yeah. And the cool thing is John Quincy Adams figured that out. And so when he was a member of the House of Representatives, he put his desk at the focus, and then spied on his political enemies who were talking at the other focus. So he just sat there and they couldn't figure it out. Why he always knew what they were talking about. Yeah, pretty cool. If you go to some science museums, they have elliptical rooms, and they have that set up for you at certain spots where you can talk it. I've done it. I think there's one in Chicago. I know there's one in Minneapolis where you can do it too. Actually, it's in St. Paul. And you go to that spot, and you can whisper and the other person across this huge room and across this crowd, lots of noise going on, and the other person hears you clear as day. Yeah. It's pretty swag. Okay? So today we are going to work through the steps to graphing. Tomorrow we'll graph. Thursday we'll go in reverse. We'll make equations on Thursday. Okay? I was going to have a quiz this week. We're not going to have a quiz this week. We're just going to push it to, I'll combine the quizzes for next week and this week. And so we'll have it next week. But you will have a formative this week. Okay? For sure now you'll have a formative. Okay? So, this is the ellipse that we are going to go with today. Okay? X minus 3 quantity squared over 9. Y plus 2 quantity squared over 16. Add those two together, it equals 1. Okay? So, what's up? You're just going to sketch it today. We'll graph it actually tomorrow. Okay? I'll graph it today, but you can just sketch it. Okay? So, what do you think the first thing that we need to find is? That center point, the middle of our ellipse, right? Okay? Where do you think the center of this ellipse is? H comma K, right? So what are we thinking? 3 comma negative 2. Because that still hasn't changed yet. Inside parentheses, we think oppositely. Outside parentheses, we think normally. Both the 3 and the 2 are inside a set of parentheses. So we found the center to be at 3 comma negative 2. Agree? Okay. So our first step then would be we would graph that center. And again, I would just put a C at that center. Okay? So now, we're going to look underneath, or next I should say, we're going to look at the denominator of the x term. In this case, it's 9. We're going to take the square root of that number. So what's the square root of 9? 3. Okay. And from the center, we're going to go left 3 and right 3. 1, 2, 3. 1, 2, 3.
Good question.
I'm answering.
For going to just write just a normal A and stuff, A equals the number, so would you do plus minus 3 or just 3?
Well, the plus and minus, you would add 3 and you would subtract 3. So yes, you would do plus and minus 3 to the center. So our center again was at 3 comma negative 2. So if I plus or minus 3 to that x part, because it's underneath the x, 3 plus 3 is 6, so that would be at the point 6 comma negative 2, which is that one. And 3 minus 3 would be at 0 comma negative 2, which would be at that one. Okay? Now, those are going to be the end points of one of your two axes. There are two axes in an ellipse. There's a minor axis and there's a major axis. Okay? The minor axis is shorter than the major axis. Major axis is longer. It's the stretched axis. If those axes are equal, you got a circle. Okay? But you're stretching one of them out. Okay? So, next, what do you think we're going to look at? We're going to look at the underneath the y. Yep, let me refresh our memories here. Let me go C there, Let me go 1, 2, 3 there, 1, 2, 3 there. Okay? So now I'm going to look at the number underneath the y squared. Again, I'm going to square root that value. 16 square rooted is 4. It's plus or minus 4. So I'm going to add 4 to my center. 1, 2, 3, 4. This time now I'm going in a vertical direction, and I'm going to subtract 4. 1, 2, 3, 4 from my center. Okay? Now that I have all of that information in there, I can draw in my ellipse. Okay? And now we can answer a few extra questions. Okay? The first extra question that we can answer is, which one is the major axis? In this case, is our horizontal axis or our vertical axis the major axis? Why vertical? Because it's longer. Yep, exactly. Okay. So in this particular case, our vertical axis is longer. Okay. So our vertical one is the major axis. Okay. Which then allows me to get what is called the vertices. The vertices are the endpoints of the major axes. So my center was at 3, -2. We said that our vertical axis was the major axis. So those two endpoints are my vertices. And those are the points 3, +2 and 3, -6. Because I add 4 to -2 and I subtract 4 from -2. We can also answer the question about which one, bless you twice, is the minor axis. And in this case, it was the horizontal. So if you look at the original equation of an ellipse, whichever denominator is bigger, that's going to tell you which one is your major or minor axis. Okay? Bigger number is the major axis, smaller number is the minor axis. Okay? So we have centers, we have major axes, minor axes, we have vertices, but we also have something called foci. Okay? And that's the last thing that we need to find. The foci are located on the major axes. They are inside the ellipse. Okay? They are inside the ellipse, which is why they're on the major axis. Okay? The way we find them is c squared is equal to the absolute value of a squared minus b squared. Okay? So the denominator of the x minus the denominator of the y, take the absolute value of that, that gets you c squared. C is the distance from the center to the focus. So in this particular case, a squared is 9, b squared is 16. So c squared is going to be the absolute value of 9 minus 16. 9 minus 16 is negative 7. Absolute value of that is positive 7. So c squared is equal to 7. But that's c squared. C is the square root of 7. Okay? Because I have to find just c. That, along with the fact that your major axis was vertical, and y is the vertical variable, the square root of 7 is going to be added and subtracted to the y value of the center. So the two foci are located at 3, comma, negative 2 plus the square root of 7, and 3, comma, negative 2 minus the square root of 7. Okay? That's where the two foci are located. If it was horizontal, if the major axis was horizontal, then we would have added and subtracted it to the x term. But because it was vertical, we added and subtracted it to the y term. Okay? So, to recap, what we do is, the first thing we find is the center. Okay? And that's h comma k, like we've been doing for a couple weeks now. Second thing we do is we look at the number under our x part. We take the square root of it, and that's going to tell us how much left and right from the center we go. Third thing we do, we look at the number under the y, take the square root of that, and that's going to tell us how much up or down from the center we go. One of those is going to be your major axis. The endpoints that you find then of that, those are your vertices. So you could find the vertices next. Step 4 you're just going to draw it, which means you're really going to graph it. Okay? So you're going to fill it in, I should say is a better one. Okay? And then lastly, you're going to find the two foci. And those will be inside. Okay? So the odd ones there, step 1, step 3, and step 5, all produce points. Okay? Step 1 gives you 1 point. Step 3 gives you 2 points, 2 vertices. And step 5 gives you 2 more points. The foci. Yes, ma'am.
So say that like instead of square root of 7 it was like 2. So then would it be 3 comma 0 and 3 comma negative 4?
Yeah, if it's a nice, yeah, then do it by all means. But if it's not, which probably 8.5 times out of 10 it's not going to be nice. Yeah. Okay. And then on your graph you could estimate where those points are. So like the square root of 7 is what, 2.8-ish, somewhere in that range. Okay, all right. So my foci, I would go up 1, 2.8. I'd go down 1, 2.8. So there would be my 2 foci. Okay.